Hello and welcome to another session of the Streaming School. Thank you very much for joining us again. I'm really pleased to have Mr. Sam Winch with us today. Good morning, Sam. How are you, buddy?
Yeah, good morning, everyone. Good morning, Leon. Leon, I'm good. I'm good, thanks. It's Monday. Wow. Ready to go for another week of Streaming School.
Yeah, quite a grey day this morning. I don't know where you are in the country, but it's quite grey, quite overcast. I think we're going to have rain the whole week.
Yeah, that's what I've heard. But I'm just hoping everyone can find something to do at home and keep themselves busy and keep their minds ticking and keep themselves occupied with something. I've got a load of Sudoku today to do, so that's my day plan.
Right, brilliant. Well, but yeah, I hope we get as much out of this as we have in all your other sessions. Thank you so much again for volunteering your time and for helping out. And I think I told you last time some of the views from Monday, Tuesday last week. We had an average of 5,000 people a day looking into the different levels of different things, and we've become very popular in India, of all places. So yeah, thanks. Only thanks to people like you that we can do this, and I really really appreciate it, buddy.
Yeah, no worries.
So the floor's yours. Get ready to share your screen whenever you want.
Brilliant. Okay, well, thanks, Leon, and welcome back, guys. First of all, welcome to today. Today we'll be focusing on angles. Still, we're gonna pick up from where we left off on Friday, as well as spending a good 10 minutes today looking at past GCSE exam questions. Yeah, Leon, if you can share my screen.
I don't think you've shared it with me initially, buddy.
That's probably why. Bear with me 1 second.
Too engrossed in chat.
It's Monday. Apologies, guys. It's Monday. That's why.
Yeah.
The entire screen. There we go. Share now. Okay. And just double check with yourself, Leon. You should be able to see my screen of recap.
Yes.
Once it's finished loading.
Perfect. It's up and live.
Okay, so guys, yeah, welcome back. So we're going to look at recapping first of all. On Friday, we spoke about initially the sum of angles at a point. So of course, the sum of angles at a point adds up to 360 degrees. Now, the likelihood in the question is that you're going to be given 2, possibly 3 angles already. So obviously, then you just subtract them from 360 or add them all up and find the difference. One of them, you might be given 2 angles, and the third one may be using algebra notation, or 2 of them may be given algebra notation. So it's about sharing the like terms and subtracting that from 360 degrees. But sum of angles at a point is 360 degrees. If you remember that, you'll be just fine with that question. Angles on a straight line, nice and simple, adds up to 380. And we're going to be working on parallel lines today. So angles on a straight line adding up to 180 is going to play an integral part to that. Angles in a triangle, same thing, 180 degrees. Remember, you'll probably be given 2 angles, therefore subtract those 2 from 180. With this one, you're given 2 angles because we know that this is 90 degrees. Okay. Then we look at angles in the quadrilateral. They all add up to 360, whether it's a trapezium, a kite, a square, whatever adds up to 360 degrees. And here, this question, for example, was looking at the external angles of a quadrilateral, which we know add up to also 90 degrees in terms of the exterior angles, of a quadrilateral. We'll talk about that later on today. Here, if the external angle here is 304 degrees, and the internal angle would have been 56 degrees. Okay, so then we looked at vertically opposite angles, alternate angles, supplementary and corresponding. Now they're all talking about similar things. This is looking at parallel lines where vertically opposite, alternate and supplementary are equal. And we talked about the Z form for alternate angles, and the corresponding angles was the F that we used. Now they are equal to each other, and the supplementary angles is where they add up to 180 degrees. So if you like, they're the internal angles of a parallel line. Okay, so there's a recap of what we did last week. We're just going to quickly look at a couple of examples on my screen here of angles, and they are on parallel lines. So if we can use again the terms alternate, supplementary, corresponding and opposite, and we'll look at how you could possibly answer these. So initially we're going to go with question A. We've got B. We'll just do the first picture at the top to start off with. There you go. A, B, C and D. And if we look at it, we've got A is on the same line as 135 degrees. So what do we know about 135 degrees and angles on a straight line? They add up to 180. So of course 180 minus 1.5 would give us 45 degrees. So we know therefore that A is 45 degrees. Now there's a lot of things we can say about B. First of all, it's on a straight line with A, so therefore it must add up to 180. But it's also vertically opposite 135 degrees. So therefore B would also be 135 degrees. And now if we use the term alternate angles, then we could look at number B and C for alternate angles. So therefore if B is 135, C must be 135 degrees. And then if we were to look at corresponding, remember that's the F formation, then B and D would be 135 degrees also. Okay, so there we've used vertically opposite, we've used alternate for the letter C, and we've used corresponding for the letter D. And if you look down here, we've got EFB. Again, you've got angle on a straight line is 180, so that would help us answer E. You could use opposite angles for E and F, so they would be the same. You could use supplementary angles for F and G. So if F was 151, of course G would just be 29, because they both add up to 180. And if G is 29, then sorry, I beg your pardon. If E was 29, F would be 29, so therefore G would be 151, and therefore H, which is vertically opposite, would be 151. Okay. Right, so we've looked at parallel lines. Today's lesson we're going to be looking at introduction into polygons, interior and exterior angles of a polygon, and some past GCSE paper questions, excuse me, on angles. Okay, so the main focus today is the interior and exterior angles of polygons, but of course you need to know your polygons first. And I'm going to complete a worksheet for you now, based on just remembering your polygons. Okay, so we're going to start off. I've got 8 pictures here. If I can just zoom out a little bit to give you a clearer picture. You've got, first of all, the triangle here. Of course, we know that our triangle is 3 sides. And our 4-sided shape is our quadrilateral. Of course, that there initially looks like a square, and it probably is. We don't know because it hasn't got an anti-degree boxes in here. So it could be a rectangle, although if I measured that, I'm sure it'll give you a square. Any 4-sided shape is quadrilateral. Okay? And we'll move on to, of course, your 5-sided shapes, which is your pentagon. Your 6-sided, which is hexagon. Oh, that's 2, excuse me. 7-sided shape, which is your heptagon. And septagon. 8-sided, which of course is your octagon. 9, which is your non-octagon. And finally, you've got 10. 10 years is a decade. Decagon. So, obviously, recognizing the names of the polygons is important, is a must, but knowing not only the sides, but the internal angles of a regular. So remember the difference between a regular polygon and irregular polygon would be that a regular polygon has the same angles throughout. So this triangle here, if it was a regular polygon, a regular triangle, it would be 60, 60, 60 degrees because they add up to 180 degrees. I know that, and I'll tell you how later on in the tutorial. Quadrilateral, we know, adds up to 360 degrees, therefore the internal angles must be 90 if a regular quadrilateral. And finally, if it's a regular pentagon, it's 540. And we know that because if I did 540 divided by 5, I would get myself 108. Okay? And we're going to work out how to do internal and exterior interior and exterior angles in the polygons shortly. In fact, if we click onto my next page, this is all the information that you need to know. However, what we can do shortly is give you a formula which will help you with the size of exterior angles, the sum of all interior angles, and the size of an interior angle as well. So the size of exterior and the size of one interior angle. And we can go in your GCSEs from anything up to a 3-sided shape to, they might ask you for a 50-sided shape or 30 or 100-sided shape. So as long as you know the formula, then of course you can answer the question. Okay, in terms of the formula, you've got it here on your screen with you. And we in terms of number of sides, we use the letter n. So to find the exterior angle of any polygon, all we have to do is divide 360 by n. So again, if we went back to my quadrilateral theory, that a quadrilateral adds up to 360, we know that. So what is the exterior angle of a quadrilateral? Well, 360 divided by 4, because there's 4 sides, which would give me 90. So the exterior of a quadrilateral is 90. The interior of a quadrilateral is also 90. We'll check that out in a second. The sum of all interior angles, well, we said that a quadrilateral is 360, because n, which is 4 minus 2, and that's the formula every time. We always minus 2 when working out the sum of interior angles. N minus 2, which gives us 2, multiplied by 180 degrees, gives us 360 degrees. Okay, so that's the sum of all the interior angles. And then finally, the size of one interior angle would be, again, 4 minus 2 times 180, which gives us 360. And 360 divided by the number of sides, which is 4, would give us 90. Okay, so with that formula in mind, it's probably a good idea to take note of this formula here for these three. With those three in mind, we can have a go at answering this question on my screen. If I can just flip back to my visualizer here, brilliant. So we're going to have a go at some of these. Now, there's so many different ways we can work these out. First of all, we know that that shape 2, 3, 4, 5, 6 is a hexagon, and I would first of all ask what's the sum of all the interior angles of this hexagon. So if it's a hexagon and I know n minus 2 times by 180 would give me the sum of all the interior angles. But if I just replace n with 6, because there's 6 sides, and minus that by 2 to give us 4, and 4 multiplied by 180 gives me 720 degrees. So the sum of all the angles within this hexagon is 720. Now, what about if I said it's a regular hexagon? So what's one angle within that hexagon? Well, I just go 720 divided by 6, which of course gives me 120 degrees, of course it does, 120 degrees. So one of those angles here, and we use the angle F, must be 120 degrees. Here the angle B, you can see, is 120 degrees. D would be 120 degrees, but there's a line going halfway through the center of the polygon. So with that in mind, I'm going to go with my first letter, the letter D. If the angle is 120 degrees and it's split into 2, then we know that each angle at D is 60 degrees. Now, within this question, it said that there was an equilateral triangle here, E to D, D to A is a equilateral triangle. So therefore, this angle here would be 60 degrees as well. Other angles, so if we look at A here, we know that C is 90 degrees. So therefore, this part, it would have to add up to 120. So therefore, 90 subtracted from 120 gives me 30. And I can add 30 to B to give me 150 altogether. And of course, if we subtract that from 180, that gives us the total for A, which would be 30. Okay, so there's a load of different ways in which to work out internal angles of any polygon. There's just a few examples for you of how to do a hexagon. Okay, and don't be afraid if they've given you lines within that hexagon. Just work out each shape on its merit. We know here there's a quadrilateral here. So we know that these angles would have to add up to 360. So if you ask me what F was, I might work out all the angles here and then take this part, which would add up to 120. And therefore, I'd be able to work out the remainder of this shape. This line here is a straight line. So we know whatever this angle is, initially we said it was 60. So if that's 60, then therefore that must be 120, because we know that on a straight line angles add up to 180. Okay, so loads of different ways there to work out interior angles of a polygon. Now, when we look at exterior angles of a polygon, we know that they must add up to 180. Exterior angles of a polygon add up to 180. that's, if you were to draw a straight line, we would know on this angle here, it would be 180. Now, around a point, of course, they're going to be 360. Or if we were to add up every single one, so the sum of all the exterior angles, then we would get here 360. Okay, so an angle on its own would be 180. So A, for example, would be, depending on what this angle here is, it would add up to 180. But if we were to add A, B, C, D, E, then it must be 360. Okay, so that's what this formula here is referring to. Okay. Now the thing is with this, we know that this polygon here is a irregular polygon, so all the angles would be slightly different. But again, we added up the full sum of the exterior angles; they would add up to 360. Okay, so here's a little example for us. If I can flip back to my visualizer down here, we want to know what x is equal to. So we know first of all that on this straight line here, with angle E, because this is a quadrilateral, we know that there's four sides to the polygon. So we know that this angle here is 90 degrees because they have to add up to 180. The internal angles of a quadrilateral is 90 degrees. So the exterior angle of this quadrilateral is also 90 degrees. So therefore, to find out what x equals, we're going to have to find out what the angle is. Now it's a six-sided shape. We go back up here that we know 120 degrees is the total of the six-sided shape. So what would the exterior angles of this shape be? And it would be 180 subtract 120 to give us 60 degrees. Okay, so now we can start to work out what the angle of E is. X, and if we did 60, add that to 90 degrees, we would get 150 degrees. So x would equal 150 degrees. Okay, so here you're just adding two shapes, the exterior of both a hexagon and a quadrilateral, to find your answer. Okay, and for the last couple of minutes, I just want to share my screen and go through a couple of GCSE past paper exam questions. So these are real life questions, if you will. We'll start off with the trapezium ABCE, and it's made from a parallelogram ABCD and the isosceles triangle ADE. So first of all, we know that A and E are the same as D and E. How do we know that? Well, if you look on the screen, you've got the line that gives us the information that these lines are the same length, and therefore have the same angles at the end of them. Okay, we also know in a parallelogram that diagonally opposite angles, so B and D, are the same. So let's have a look then. If we know, visualizer, if we know that D equals 110 degrees, then we know the other side of D must be 70 degrees, because we know that on a straight line, angles add up to 180 degrees. Now, if that's the case, the angle A within the isosceles triangle must also be 70 degrees. And two lots of 70 degrees gives us 140. And within our triangle for the letter E, we know that 180 degrees, subtract that by 140, gives us 40 degrees. So E would equal 40 degrees. Now it says work out the size of angle AED. That means you're working on, you start letter A to E to D, we're working at this angle here, and there's the answer, 40 degrees. Okay, so there's one example, and if we move on, in fact, actually what we've got here is the mark scheme, which I thought I would show you. This is the GCSE mark scheme and how they look to give you 3 marks. I worked out that ADC is 110 degrees because we know it's diagonally opposite in a parallelogram, so that will get you your first mark. And then all we're looking to do then is to subtract 110 from 180 to give us 70. And 2 70s, as you can see down here, allows us to work out that 140 is the total of the triangle and 40 degrees is remaining. So with the M1, remember that's a method mark. So if you're doing the correct method, which we went through there, as well as getting the right answer, you would get 2 to 3 marks. And it's a 3-mark question, so you'd get 3 marks for that one. Okay, I think we've got time for one more GCSE style question, and simply is the term congruent. So congruent just means the exact same. So it's the exact same degrees, same size of sides. So So the length of each side is the same, but it might be rotated or reflected or translated. Okay, so a little bit of transformation as well. And it says circle 2 letters below which two triangles are congruent. And we know that it would be the letter A and the letter D. And the reason why is because the hypotenuse here, the longest side is 8 centimeters, whereas the longest side here, we don't know how long it is, nor here, whereas A is also 8 centimeters. Leon, if you can share my screen, please. So I hope you found today's tutorial helpful. We worked through angles, and we worked through interior and exterior and external angles on polygons. We also did a little bit of recapping on what polygons are. So make sure you know all the properties of your polygons. I've got more GCSE style questions for you that we're going to look at on Wednesday. But other than that, have a good day, and I hope you enjoyed today's tutorial.
Thank you so much, buddy. Really, really appreciate it. And a small apology from us, Sam, just from the internet, and also with the streaming. If the sync you notice is 4 to 5 seconds out, we'll be changing that and updating it for one that is back on time, and we'll be fixing that in the interim break. So sorry about that, Sam. It's just a few seconds out. We just had a couple of messages, but I didn't want to cut it live stream. So yeah, that's the wonders of working with technology.
Cheers, yeah, cheers, guys. Have a good day, everyone.
You too. Look after yourself, buddy.
Cheers, mate. Bye-bye.
Bye.